Hello, and welcome to this presentation, Understanding AC Breakout Boxes. In this presentation, we'll explain the purpose and use of breakout boxes when making voltage, current, and power measurements on AC mains connected devices. As you should already know, power is the product of voltage and current, and thus AC power is measured by simultaneously measuring AC voltage and AC current, and then multiplying these two quantities. In the case of AC mains connected devices, voltage is measured between the line or hot conductor and the neutral conductor. In North America, these are usually the black and white wires. Current can be measured on the line or on the neutral conductor, either by breaking the circuit and placing the measuring device in line, or by using a non-invasive clamp-style sensor or probe. Note that if a protective ground exists, this conductor should only be carrying current during a fault condition, and therefore this conductor is generally not used when making AC power measurements. Instruments that can be used to measure both AC voltage and AC current fall into three main categories. The first is standard digital multimeters. To make AC power measurements, one meter is used to measure voltage, and another meter is needed to measure current. Sometimes a clamp-style meter is used for this measurement. Note that a small number of multimeters are, however, capable of measuring voltage and current simultaneously. A more convenient and more accurate way of measuring AC power is using an oscilloscope. Here, a differential voltage probe is used to measure the line to neutral voltage, and a current probe or shunt is used for measuring current. However, the easiest and most accurate method of measuring AC power is using a dedicated power analyzer. These provide direct banana jack connections for both voltage and current, although external clamps or sensors may be used when measuring very high voltages and currents. But in all of these cases, we still need some way to safely connect to the AC mains voltage and current measurement points. AC breakout boxes provide this safe and convenient connection method by means of sheathed 4mm or banana-style plugs. There are typically 4 connection points on a single-phase AC breakout box, 2 for measuring the voltage across line and neutral, and 2 that allow an in-line connection for measuring current. Note that in order for current to flow through the box, the 2 current terminals must be connected, either via a jumper or through the measurement device. AC breakout boxes are available from numerous commercial manufacturers, but they can also be easily self-constructed. In both cases, but particularly in the case of homebrew boxes, care should be taken to ensure that the box can safely handle the expected maximum voltages and currents. And if a protective ground or earth connection exists, this is simply connected through. Most often, an AC breakout box has a power cord for connecting to AC mains, and a plug or outlet for connecting to the device under test. As mentioned a few moments ago, voltage and current connections are made using standard banana-style plugs. Some variants use standard power cords for making the AC connection to both mains and to the device under test. Note that some AC breakout boxes have a wiring diagram on them, in addition to the labeled jacks. These first 2 examples have 4 jacks, 2 for voltage and 2 for current, but some boxes have only 3 banana jacks. We'll explain this in more detail shortly. And finally, there are also breakout boxes which plug directly into an outlet and do not need any kind of cable for connecting to AC mains. And although not illustrated here, switches are sometimes incorporated into AC breakout boxes in order to either disconnect power or to change the measurement voltage range. Almost all AC breakout boxes have standard regional plugs or receptacles. For example, the NEMA 515R in North America, or the 2-pin Schuko connector in Europe. Some boxes have so-called universal plugs that allow the connection of DUTs from different regions. These often have various physical formats or arrangement of sockets to accommodate as many different plug styles as possible. Another flexible approach is a breakout box that accepts standard power cords. These boxes have the international standard IEC 6320 couplers, and this allows the use of cables with the IEC plug on one end and a regional plug on the other end. Next, let's go through some connection examples, starting with how to use a standard breakout box with an oscilloscope. Our breakout box is connected between AC mains and the device under test. A voltage probe is connected to the voltage jacks on the breakout box. Note that in most cases, differential probes must be used rather than single-ended probes. A common way of measuring current is to jumper the current jacks of the breakout box, and then use a standard clamp-style current probe to non-invasively measure the current through this jumper. Recall that the current jacks must be bridged in order for current to flow through the breakout box. Here's how we would connect a breakout box to a measurement card and a power analyzer. As before, the breakout box is placed between AC mains and the device under test. The connections in this case are, however, much simpler than those used with an oscilloscope. The voltage jacks on the breakout box are connected to the voltage jacks on the analyzer, and the current jacks on the breakout box are connected to the current jacks on the analyzer. Note that somewhat different connections may be needed if external probes are used for measuring very high voltages and/or currents. The last example we'll look at is connecting a 3-jack AC breakout box to a power analyzer. The AC mains and DUT connections are made as in our previous examples. Current connections to the power analyzer are made between the current and common jacks on the breakout box. But the voltage measurement connection is made between the voltage jack and the current jack. Note that in this case there is no need for a jumper between the current measurement points. Before we conclude this presentation, let's talk briefly about 3-phase AC breakout boxes. Like single-phase boxes, these typically provide a standard plug and receptacle, such as the CEE 5-pole connector shown here. They also provide sheathed banana plug connection points for each of the 3 line conductors, as well as for the neutral conductor. These sockets can be used for measuring between each line and neutral, as well as between neutral and the protective earth or ground. It's also common for these types of breakout boxes to contain an integrated circuit breaker for safety. Let's end with a brief summary. Power measurements require simultaneous measurement of both voltage and current. Various instruments can be used to perform these measurements, but making the measurement connection to AC mains powered devices can be both difficult and/or dangerous. AC breakout boxes are therefore used to provide a safer and more convenient way to make these voltage and current measurements on mains-connected devices. The breakout box is plugged into AC mains, the DUT is plugged into the breakout box, and sheathed or shrouded 4mm banana jacks can then be used for the voltage and current measurement points. In this presentation, we looked at some of the different styles and form factors of AC breakout boxes, along with typical wiring connections. And finally, while most AC breakout boxes are used for single-phase AC measurements, specialized boxes are also available for the measurement of 3-phase AC power as well. This concludes our presentation, Understanding AC Breakout Boxes. If you'd like to learn more about AC power measurements or AC power measurement instruments from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.